University faculty are currently facing a unique dilemma. We are handing our students a technology capable of near-perfect conversational fluency, yet it possesses absolutely zero actual understanding. This disconnect was diagnosed in 2021 by researchers Emily Bender, Timnit Gebru, Angelina McMillan-Major, and Margaret Mitchell. They coined a precise term for these models, the stochastic parrot. Looking at this visual breakdown, a stochastic parrot operates entirely on mathematics. It calculates the probabilistic distribution of words. As the researchers put it, the model is haphazardly stitching linguistic forms without reference to meaning. It lacks any internal mental model of the physical world. When students mistake this mathematical fluency for actual human thought, they fall into a trap. This illusion of comprehension is what ultimately compromises both academic integrity and their own critical thinking. Consider what happens when a student enters a prompt into a large language model. The system doesn't research a factual answer. It breaks that prompt down into a sequence of statistical probabilities. This diagram illustrates that probability tree. The AI rolls the dice within a specific percentage distribution, choosing an 80% likelihood word over a 15% one, to select the next term in the sequence. It creates the illusion of creativity through controlled randomness. If a student accepts this statistical guessing game as a definitive truth, they stop actively learning. They devolve into a passive consumer of information. This framework categorizes that behavior as the passive user. The student treats the AI as an infallible answer engine, limiting their inquiry to simplistic what questions. They become trapped inside the prompt loop, blindly trusting the output without verifying it against external reality. If our syllabi focus solely on teaching prompt engineering, we are merely optimizing this loop. We leave our students permanently positioned as passive consumers of an ungrounded system. To diagnose why this happens, we can look to cognitive science, specifically the framework presented in Douglas Hofstadter's book, Gödel, Escher, Bach. It explains exactly why an AI cannot self-verify its own outputs. Hofstadter defines a formal system as a rigid, rule-bound structure. It is highly effective at manipulating symbols based on set parameters, but it does so without inherently understanding the meaning behind those symbols. Looking at this structural blueprint, we see large language models operate entirely as closed formal systems, isolated from the physical world. Because the system's foundation is closed, the symbols manipulated inside remain entirely abstract. They are disconnected from any verifiable truth. This brings us to grounding, Pillar 2. It's the mandatory process required to extract value from a closed formal system. Grounding data provides specific external information. It forces the AI to draw from factual content to generate accurate responses, rather than hallucinating. Without a deliberate mechanism to ground the AI's abstract symbols in a verifiable reality, the formal system's output remains completely untrustworthy for academic work. This shifts the problem from computer science to instructional design. A standard lecture-only course format cannot provide the active grounding mechanism that these AI tools require. The most effective pedagogical framework to supply this missing anchor is David Kolb's experiential learning theory. We can isolate the concrete experience phase of Kolb's cycle. This requires immersing learners in highly contextual, real-world information gathering. When instructors deploy authentic, project-based learning assignments, they force students to generate their own proprietary, verifiable datasets. This diagram illustrates isomorphism, the structural bridge linking the closed AI system to the physical world. Here, isomorphism means mapping the AI's abstract claims onto a real-world source of truth. The student's raw project data serves as the heavy anchor stabilizing the AI's probabilistic drift. From an instructional standpoint, the action is clear. Students must actively test the AI's generated insights against the concrete data they gathered during their own project. Experiential learning serves as the structural countermeasure required to safely operate ungrounded AI systems in the modern classroom. When a student realizes the AI's phloem output directly contradicts the concrete data they collected themselves, it creates a moment of intellectual friction. This diagram introduces Pillar 3, ethics. It asks who or what the AI is imitating. Hofstadter describes a human cognitive ability called jumping out of the system. the capacity to pause, step back, and survey the governing rules of the system itself. Testing the AI against experiential data forces this exact metacognitive leap. It physically pulls the student out of the prompt loop. In the full architectural model, we see the user's elevated position. From this observation deck, the student isn't trapped in the cage with the stochastic parrot. This perspective allows them to identify the AI's inherent biases, recognize blind spots, and evaluate its limits. True ethical use of an AI tool is impossible from inside the prompt loop. It requires the metacognitive distance to survey the system's boundaries from the outside. Returning to our behavioral framework, we see the contrast between the passive consumer and our ultimate pedagogical goal, the active surveyor. The active surveyor doesn't treat AI as an oracle, but as a bounded formal system with mathematical limitations. Notice the shift in inquiry. The active surveyor stops asking the machine what and uses their grounded data to ask how and why. This advanced user demands grounding and enforces isometrism before accepting any generated output. By architecting our syllabi around Kolb's concrete experiences, we alter the power dynamic between the student and the machine. Attempting to ban AI from the university classroom is futile. However, teaching basic prompt engineering and calling it AI literacy is a dereliction of our academic duty. Compare a traditional, ungrounded essay prompt to a modern, data-driven experiential assignment. In the latter, AI is restricted to synthesizing the raw data the student provides, rather than generating the ideas from scratch. The instructor's primary role is to design authentic, friction-heavy concrete experiences, the physical realities that a large language model cannot simulate. This pedagogical shift connects directly to the core mission of our institution. We are tasked with preparing students for real-world leadership. Our goal is to equip students with the critical metacognition required to govern the automated systems that will define their professional futures.